Hello everyone. Today I am going to discuss a very important part of your course, programming for problem solving. Today's topic is array of pointers and pointer to an array. So you are already familiar with arrays as well as you are familiar with pointers. Now, what do we mean by array of pointers? You are familiar with array of integers, array of floats, array of characters. So why not array of pointers? And what do we mean by array of pointers? So array of pointers is actually a collection of pointers. Okay, just like array of arrays, array of integers is a collection of integers. Similarly, array of pointers is a collection of pointers. And those pointers or those addresses should be stored in consecutive memory locations by the definition of an array, So we can visualize this one by an example, a programming example. It is shown over here. Here, int star p within third bracket 4. This is the way how we can declare an array of pointers. So here p is actually an array of 4 pointers, each of which points to an integer. So we can take 4 variables of type integers, int I, j, k and l, and we have initialized by some values to these variables. And here you can see I have taken 4 pointers and I have initialized these pointers by the address of some integer variable. So P0 is one pointer which is initialized by address of I. P1 is another pointer which is initialized by address of j. P2 is another pointer which is initialized by address of k. And finally P3 is another pointer which is initialized by address of l. So there are 4 pointers, P0, P1, P2 and P3. So we can consider these are an array of 4 pointers. So you can visualize this by the following figure. So for I, for j, for k and for l, 4 distinct memory locations are assigned by the compiler whose addresses are random address provided by the compiler 2000, 9060, 874 and 1026. And whenever I have used P0 is assigned by address of 1, this type of address of I, this type of statement, then 2000 is going, or 2000 is going to copy to the memory location allocated for P0. So P0, P1, P2, P3, they are also variables, they are pointer variables. So for P0, P1, P2, P3, there will be memory allocated, there will have some memory locations allocated by the compiler. And as they are array variables, or they are of type array, hence the memory will be allocated for P0, P1, P2, P3 will be consecutive. That means 65520 if the base address of this array of pointers, then P1 will have an address 65524, P2 will have an address 65528, and P3 will have an address 65532. You can see there is a difference of 4 because a pointer is of type unsigned integer, and any unsigned integer, you know, it takes 4 bytes. So there is a difference of 4 byte memory locations. You can see here. And by the statement P0 is address of I. So what is address of I? It is 2000. So 2000 is going to P0. So by the statement P1 is address of J. What is address of J? It is 9060. 9060 is going to P1. Okay. And by the instruction or by the statement P2 is assigned by K, is assigned by address of K. And what is address of K? It is 874. 874 is going to P2. And finally, P3 is assigned by address of L. And what is address of L? It is 1026. 1026 is going to P3. Okay. Now, you can see this printf statement which prints the addresses and value at their addresses. So, if m is a loop variable which starts from 0 and continue up to less than 4. So for P0, what is P0? P0 is 2000 and start of P0, start of P of m, that means start of P0, the value at address P0. What is P0? P0 is 2000. So start of 2000, start of 2000 means the value is present, the value which is present at 2000 is 31. So 2000, 31, and it is written here. You can see this is output. Similarly, when m will be incremented by 1, so P of 1 means 9060 and star of P of 1 means value at address 9060 which is 5. So here is the output, address 9060 and value 5, and so on. Okay, so this is the scenario. So you remember this is the notation whenever we are going to declare an array of integer pointers or array of pointers. First type, then space, then star, then name of the variable. After that, within third bracket, size of that variable, size of that array. Okay, so in star P third bracket 4 indicates P is an array of 4 pointers, each of which points to an integer. Now we are going to discuss an important part, another important part, which is pointer to an array. Again, we know pointer to an integer, pointer to a float, pointer to an char. So why not pointer to an array? So how we can declare pointer to an array? It is highlighted here, int within first bracket third star q and then within third bracket 4. Here q is known a pointer to an array of 4 integers. So remember, in the previous example, we have discussed array of pointers. But in this particular example, we are discussing about pointer to an array. So here q is actually a single pointer. In the previous example, P was a collection of 4 pointers, but in this example, we are discussing pointer to an array. Here Q is a single pointer, but it does not point to a particular integer. It does not point to a particular floating point. It does not point to a particular char, but it points to a collection of integers, an array of 4 integers. So Q is actually a single pointer, but it is pointing to an array of 4 integers. Okay, so here we have taken a 2-dimensional array, row size 3 and column size 4, 3 cross 4 matrix on 2-dimensional array. There are 3 rows and 4 columns, total 12 number of elements. And P is a simple integer pointer, but Q is a pointer to an array of 4 integers. And we have initialized P and Q by the same thing that is address of array 00. Address of array 00 is nothing but the base address or starting address or initial address of the array ARR. Okay. So let me show you the diagram. So this is a 3x4 matrix or array, two-dimensional array, where this is array 00, this is array 01, this is array 02, this is array 03, this is array 10, array 11, array 12, array 13, this is array 20, this is array 21, this is array 22, and this is array 23. It's 3x4 matrix or 3x4 array, 2D array. If we assume the starting address is 2000, then the address of the second element will be 2004, the address of the third element will be 2008, the address of the fourth element will be 2012, and the address of this element, the element 4, the element whose value is 4, the address of that element will be 2016, and so on. We are incrementing by 4 plus 4 plus 4 plus 4 plus 4 because one integer occupies 4 bytes. Now come to the program. So whenever you write this statement printf %u, p, q, that means we are printing the base address of this corresponding array. So it will print 2000, 2000. Okay, or 2000 space 2000. But whenever you apply this type of statement, p++ and q++, for p++, it is simple increment of a simple pointer. So p++, after p++, p will be 2004 because it will point 7. Okay. But what's about q++? Now you can see here that q is a pointer to an array of 4 integers. So q is pointing to a collection of 4 integers as a whole. So whenever you are incrementing q one times, it will point to the starting element of the next row, or it will jump to the 5th element of our array, 2D array. Okay, so what is the 5th element of our 2D array? If this is the first element, this is the second element, this is the third element, this is the fourth element, that means element whose value is 5 is the first element, element whose value is 7 is the second element, element whose value is 6 is the third element, element whose value is 9 is the fourth element, and element whose value is 4 is the 5th element. So it will jump 4 integers and it will point to the element which is 4. Okay, this starting element of the second. And what is the address of element 4? It is 2016. So if we write q++ and after that if we print q, it will not print 2004 but it will print 2016. That's the concept. So if you again increment p and q, p will point to the very next element. That means p will point element 6. So p will be 2008, but q will point the element 2, and the address of element 2 is 2032. So if we print q now, it will be 2032. Okay, so what is the concept? The concept is that as q is a pointer to an array of 4 integers, if we increment q, it will point to the starting element of the next row. That means it is pointing to a particular row at a time. You can consider in this way. So whenever you are incrementing q, it will point to the starting element of the next row. Again you are going to increment q, so it will point to the starting element of next row, and so on. Okay, now instead of taking two-dimensional array, we can apply the same concept using 1D array. So let us show you another example where I have taken ARR is an array whose size is 12. Okay, and these are the elements which we have initialized here, and it looks like this. The array 0 to array 11, these are the elements, and the q the concept of q is again same. That means q is a pointer to an array of 4 integers. That means q is pointing as a whole 4 elements at a time. Again, p and q is assigned by the starting address of array. Okay, so for the first time, p and q both are 2000, 2000. Here you can see at the output, that is I have written at the right hand side. And after incrementing p plus plus, p will point to the very next element, that is array 1 element whose address is 2004. But if you apply q plus plus, it will point to element after 4, after jumping 4 elements. That means if p at the beginning points to array 0 element, not p, here it is q. If q points array 0 element at the starting time, so after incrementing q plus plus, it will point the element which is array 4. Okay, and it is the value is 4, so q will be 2016. Here it is written at the output, after q plus plus it will be 2016. Again you apply q plus plus, then q will point element which is array 8. So this is element, you can consider the first element, second element, third element, fourth element for the second set of 4 elements. Then after applying q plus plus, it will jump these 4 elements and it will point to this element, that is array 8 element, which is 2. The address is 2032. So it will print 2032 if we print q. Okay, so this is a concept. Now can you tell me, if instead of in star q4, if we write in star q5, what will happen? That is presented over here in this slide. So the only change in this program is instead of 4, I have written here 5. So q is a pointer to an array of 5 integers. That means q is pointing 5 integers at a time. Okay, so if we apply q plus plus, q will point to the array 5, this element which is 8, and the address of this is 2020, so it will be 2020. So you can see after the incrementing of q, first q was pointing to array 0, and as q is pointing to a collection of 5 elements, to element number 1, element number 2, element number 3, element number 4, element number 5, these 5 elements. So if you increment q, it will point the elements which is after 5 number of elements. That means it will point array 5 or element 8. So again, if you increment q, it will point to array 10, which is 0, the address is 2040, so the output is 2040 if we print q. That is the concept, that is the scenario. So what we have learned today, we have learned two relations between array and pointers. The first one is array of pointers, where we have studied that if p is an array of pointer, that means p is a collection of pointers. And at the second part, what we have learned pointer to an array. If q is a pointer to an array, if q is a pointer to an array of 4 integers, that means q is a single pointer which is pointing to a collection of 4 integers. So that is the difference. Okay. Now we shall discuss another important part, which is relation between pointer and string. Now you are already familiar about string, and we are going to discuss a program how we can understand the relation between pointer and string. So we want to print each character of a string where a string is taken within a subscripted variable. So let us consider the following 3 examples. So if we look at the very first program here, where we have not used any pointer variable, and here we are going to print the each and every character of str string. So we have used a while loop, and we have used the condition where str I not equal to \0, where I starts from 0, and within loop I has been going to increment it and percentage stri is printed through percentage c. So str0, str1 and so on. So whenever str with some value is backslash 0, it will stop here. So it is a simple. Without using pointer, I am going to print the individual characters of a string. Now if we want to use a pointer variable, what is the change that is we require in this program? So I have taken a character, I have taken a pointer variable of type char start ptr. Here you can see, and I have initialized this ptr by address of str0. So the pointer is pointing the very starting element of our string. That means pointer is pointing to the character C, capital C here. Now here I have replaced the condition stri not equal to 0 by the not equal to backslash 0 by the statement star ptr not equal to backslash 0, and I am going to print through star ptr. Now what is happening here? Here ptr is assigned by address of str0. If we assume str0 has an address 1000, and as it is character, so str1 will have an address 1001, str2 will have an address 1002 and so on. So ptr is assigned 1000, which is the address of starting element of this string, that is address of capital C. Now star ptr, that means star of 1000, which is capital C. So C not equal to backslash 0, yes it is true, it will go within the while loop. It will print star of 1000, that is capital C, through percentage C. So here you can see the output is capital C first. Now ptr plus plus, ptr will be incremented by 1, and as it is a character pointer, it will be incremented to 1001. Now again go to the while loop. Star of 1001, it is capital O. As it is not equal to backslash 0, it will go within the while loop, printf percentage C comma start ptr star 1001, which is capital O. So capital O will be printed. And again ptr plus plus, ptr will point to the next element, that is ptr will be now 1002. And again it will go within the while loop until and unless the string ends, or it will continue up to backslash 0. Before backslash 0, it will continue within the loop. And you can see this is our output.